what we need to do is provide as much detailed information as possible. And so this age, we're going to get the range of the age range, not to be confused with the range. It's just going to be the lowest number or the youngest participant and the maximum number or the highest number, which is the oldest participants. But we're also going to get the frequency information of this data set on gender. So how many participants are male, how many participants are female, and their percentage. And then also the total sample size. And we might need to, or we will need to take account for missing data points. So without further ado, I have slightly modified this into a PPT. This is what your answer is going to look like. You're going to need to fill in the blanks, and I will give you my answers based on the not homework data set. Your data set is the diet.save. So at any rate, we're going to go into here and get started. So let me see here. So what we're going to do is go into analyze, descriptives, and frequencies. Now I've already done this, but I want to do this step by step so that you get the process. We're going to put age or gender in there, age and diet. And then we're going to click on statistics. Oh, I'm sorry, it's not diet. Ooh, what am I saying here? It's going to be participants. We're going to click on statistics, and then we're going to make sure that this is checked off: the mean, the minimum, the maximum, and the standard deviation. Because again, we want to get the youngest age and the oldest age to give us an age range. Not range, but just the age range. And then whenever we report mean, we need to report the standard deviation. And we're going to do that with our age variable, which is our continuous variable. So we're going to go ahead and click continue and make sure that display frequency table is checked off as well. Press OK. And then what we see here is the statistics box, and this has n number of participants valid. It's going to be very important this time because, as you see here, this is participant number or ID, and we have 78 participants. But notice how here in gender there are 74 valid and 4 missing. As you recall, we have 2 in the category of -99 and 2 in the category of -77. So there's a total of 4 participants missing. This is going to be very important when we write up our report of the general view of the data set, just a general feeling of it when it comes to gender, age, and total number of participants specifications. We also have the mean of age and the standard deviation of age. And then we see that the youngest participant is 12 and the oldest participant is 75. Since this is a made-up data set, I switched things around a little bit. You wouldn't get this past a review board. It's a type of way in which to decide whether people can do studies or not. It wouldn't get past that if you had this unless you had special permission. And so when we're dealing with data, you have to be at least 18 years old in order to be a part of the lab experiment or whatever type of design that you have. But in this case, this is fictitious, so for this case, it's going to be the lowest age is going to be 12, and the highest age is going to be 75. So let's go in here and fill this out as we go. So the participants were how many undergraduates enrolled in psychology course at University of XYZ? Well, as we see here, 78 is a total, or if you do 74 plus 4, that gives you 78 as a total. But 4 of them, at least in the gender category, were missing. from the data. The final sample consisted of 74 students because we didn't account for the number missing in gender, including this many men and this many women, and participants' age range from this amount to this amount, and then the mean and standard deviation. So if we wanted to know this number, frequency, and percentage, we would go down to here to the gender table. And what we see here, valid cases, female, 38 participants. And notice how it says 48.7, but we have 4 missing. So the valid percent is what we need. So if I was to go into here and just so that you can see this, right? 38 divided by a total of 74. 38 divided by 74. And this is about 51.4. So we're going to put this number in instead of the other number, which is 48.7%. That is under the assumption that we have 78 participants, accounting their gender. So I'm going to go ahead and put that in because that's the number that we're going to need, because we're basically going to throw out those 4 participants for the sake of this example. So at any rate, the same thing goes for this one. So 48.6 is going to be the valid percent instead of 46.2. And then 51.4 for females, 38 women, and 36 men. Participant age range, and we have that right here, and we just did that by looking at this. We're just going to put that in. And as you see here, we have that populated, and we can do that for the mean and standard deviation. Now I kept this to 2 significant figures to the right of the decimal point. This one we're not even going to look at because scientific notation, we wouldn't put that. So we would just keep it at 2 significant figures to the right of the decimal points. So we have this information here, and again, your information is going to be slightly different because you're dealing with a different data set. All right, so let's go ahead and move on to the next part of this. So now we're going to list and describe the pre-weight and then the Z pre-weight. What we are going to be doing is, this represents our raw score, the score that we have before we standardize. So as you recall, if we go back to here, as you recall, this is our raw value, right? 83, but then when we standardize, this becomes 1. This is another raw value. When we standardize, it becomes 2. And these are right at the standard deviations, but we're going to have something maybe in between. There's not going to be perfectly 1 or 2 standard deviations. So that's what we're going to be doing, is reporting the raw as well as the standardize. So I'm going to go back into here. How are we going to standardize this is we're going to go and look at participant 11. That's the one that we're going to standardize. But we can't just do it individually. At least for this course, we're going to standardize all of them because that's what makes sense, but we're going to focus on participant number 11. So we do analyze, descriptives, and then we're going to go into pre-weight and then click it over right here. Save standardized values as variables. We're going to check this off and press OK. And we can just ignore this, but we're able to standardize it because now look what happened to the data. So this is the pre-weight, and here is how it looks like when it's standardized. So I'm going to move this over just so it's easier to see. Give me a second here. Okay. This is a z-score. This is a raw score, and we are negative 1.63 standard deviations away from the mean. So if I was to draw this out for you, and we have this standard distribution, right? Or normal distribution, I should say, not standard, but normal distribution. And the mean is here. And when you standardize, the mean becomes 0. And then we have one standard deviation, SD. And we have two standard deviations, SD. And what we see here is that this is right about here. So it's negative 1.6 standard deviations away from the mean, which is 0. And you can see that with these other scores, they're at other locations from the standard from the mean. But we need to look at participant number 11. So participant number 11 is going to be right here. Give me a second here as I move that around. Okay, so participant number 11 for pre-weight is negative 265, and that is their z-score, and their pre-weight is 108.4. So we're going to move this around just so we can write this in. So this is kind of how the write-up looks like. Z-scores were computed for raw scores in the blank data set. My data set is called not homework. Yours is called diet.save. So this is in the not homework data set. As we see here, it's populated. And the 11th participant had a raw score of, what is their raw score? Their unstandardized score is 108.4. So that's going to be 108 for their unstandardized or raw score, 0.4. And then their z-score for this one is negative 2.65. All right, participant 11, negative 2.65. Right, so the z-scores indicate the 11 participants' pre-weight score was slightly above the average. Nope, it's slightly below the average. So we need to change that around because we see it's negative 0.265. That is below the average. We're going to put that in red just so we can see that. At a value of how many standard deviations? At the value of negative 0.265 standard deviations. That's what the z-score represents, is standard deviations.